Dear students, welcome to digital classes. Today we are going to learn an interesting topic, that is progressions. By the end of the lesson we will learn about what is sum of first n terms in arithmetic progression and what is geometric progression. In the previous session we have learnt about what is arithmetic progression and what is the general term of an arithmetic progression and what is nth term of an arithmetic progression. So the general term of arithmetic progression is a plus d, a plus 2d, a plus 3d, so on. That is the general form of arithmetic progression. Now what is nth term of arithmetic progression? That is an is equal to a plus n minus 1 into d. That formula we have seen in the previous session, and also we have solved the problems based on that nth term formula. Okay, so in the previous session we have estimated first term and common difference, nth term of AP and number of terms of given AP. So now we are interested to find what is the sum of the given AP. Is it easy or hard? How can we find the sum of the given AP? Shall we add each term individually? It will take more time. So to find the sum of the n terms of given AP, we have one formula. So in this session we are going to learn the sum of n terms of given AP, and also we will solve some related problems on that formula, and also we will learn about geometric progression and nth term of geometric progression. First question, that is find the sum of first 100 natural numbers. This question was asked by a teacher to the great mathematician Carl Friedrich Gauss. So he is the great German mathematician. When he was 10 years old, his teacher asked that question, what is the sum of first 100 natural numbers? That is 1 plus 2 plus 3 plus so on plus 100. What is the sum? He is the great genius mathematician Carl Friedrich Gauss. So what he did? So Carl Friedrich Gauss, when he was in 10 years old, so just he answered that question in a short time. So what he did? He has taken S is equal to 1 plus 2 plus so on 99 plus 100. He assumed the sum is equal to S. After that he wrote the same sequence in reverse order. So that is S is equal to same 1 plus 2 plus 19 plus 100 he wrote in reverse order, that is 100 plus 99 plus so on 2 plus 1. Okay. After that he added twice those sequences. That means by adding those two sequences what we will get, in the left hand side we will get S plus S, that is 2S, and the right hand side this 1 plus 100 is 101, 2 plus 99 101, each term 99 plus 2 101, 100 plus 1 101. So how many 101s we will get? We will get 100 times 101s we will get. Okay. So for example, if we add 3 and number 3 twice, that is 3 plus 3, how much? 6. That means 3 plus 3 is nothing but 2 into 3 twice, right? So 2 into 3, 3 has 4 times, means 3 plus 3 plus 3 plus 3 means 3 into 4, that is 12. Like that here we have 101 plus 101 plus so on 101 up to 100 times. So what is the sum? So that is 2S is equal to 100 into 101, 100 into 101. So 101 repeated 100 times, right? That's why 100 into 101. Okay. So now bring 2 to right hand side. Here 2 is multiplying. If you bring to right hand side, it become 100 into 101 by 2. 100 by 2 become 50. S is equal to 50 into 101. So 50 into 101 is 50, 50. That is 5050. So this is the way of solving. Okay. So this is the way of solving. By Gauss estimated the sum of the first 100 natural numbers by using this process. Okay. So this leads to find the sum of n terms, that is Sn for AP. Okay. So let us solve sum of n terms of an AP. Sn is equal to, what is the first term of AP? A. Second term A plus D, next A plus n minus 1th term, and the last term is nth term, that is a plus n minus 1 into d. So what is the next step? We have to write in reverse order. Here I am denoting sum of n terms of an AP as Sn. Okay, so now reverse order means this one. Write the last term, that is a plus n minus 1 into d first, later a plus n minus 2 into d, plus so on, a plus d plus a. Now add these two expressions, then left side that become 2Sn, Sn plus Sn become 2Sn, and the first terms a plus n minus 1 into d become 2a plus n minus 1 into d, and the second terms a plus d, here we have a plus n minus 2 into d, a plus a become 2a, and here d is common, then we will get n minus 2 plus 1, that become n minus 1. Sum of the last two terms also 2a plus n minus 1 into d. So this 2a plus n minus 1 into d repeated n times. So that's why the sum is 2Sn is equal to n times 2a plus n minus 1 into d. Now here 2 is multiple to Sn. Now bring to right side, you will get Sn is equal to n by 2 into 2a plus n minus 1 into d. So that is here, what is Sn? Sn is nothing but sum of n terms of an arithmetic progression. Therefore this is the formula, that is Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay, so this is the formula, and here what I am doing is 2a can be written as a plus a, right? What is this? What is a plus n minus 1 into d? In the previous session we have seen this, that is nth term, that is an. So therefore this formula can be written as Sn is equal to n by 2 into, this is a, and this term is an, and also this an can be written as L. L is nothing but last term. So Sn is equal to n by 2 into a plus L. So these are the three formulas of sum of n terms of an AP. So this is the formula, Sn is equal to n by 2 into 2a plus n minus 1 into d, and this is also. Now what is Sn? Sn is nothing but sum of n terms of an AP, and here what is n? Number of terms in given AP. And what is a? A is a first term, and d is the common difference. An is the nth term or general term. So these are the terms of Sn. We have seen what is Sn. Sn is equal to n by 2 into 2a plus n minus 1 into d, right? So based on that problem, that formula, we will do some problems. So here we have some examples. So first one is find the sum of minus 5 plus minus 8 plus minus 11 plus so on plus minus 230. So first of all, whether it is in AP or not. Obviously it is in AP. How means? Here first term is minus 5, and then find common difference. The second term is minus 8, and minus, the first term is minus 5, minus into minus become plus, minus 8 plus 5 is minus 3, and the difference between third term and second term also minus 3, minus 11 minus of minus 8, that also minus 3. So from this sequence we have estimated that A, and we have identified D, and what is this? This is the last term, right? An, that is nth term, that is minus 230. To find the sum of this given expression, first of all we should find how many number of terms are there. After that we are going to find sum of n terms. So first we have to find how many number of terms that are there in given AP. For that we have one formula, that is nth term of AP. What is the nth term of AP? An is equal to a plus n minus 1 into d. So substitute here. So we have to find n value and Sn value, right? So here we have a is equal minus 5, d is equal minus 3, and an is equal minus 230. Now what is an? A plus n minus 1 into d, which is equal to minus 230. So substitute the values of a and d here, then we will get minus 5 plus n minus 1 of minus 3 is equal to minus 230. Now bring this minus 5 to right hand side, then it become n minus 1 into minus 3 is equal to minus 230 plus 5. Minus 5 become plus 5, right? So what is the value of minus 230 plus 5? That is minus 225. Okay. Now here minus 3 is multiplying n minus 1, if we bring to right hand side, it divides minus 225. So n minus 1 is equal to minus 225 by minus 3, minus minus gets cancelled. So 225 by 3 become 3 7s 21 and 3 5s 15. So 75 is the value of n minus 1. Now what is n? N is equal to 75 plus 1. Minus 1 bring to right hand side, you will get 75 plus 1, which is equal to 76. So we got n is equal to 76. That means in the given AP, the total number of terms are 76. Now we can find sum of those 76 terms in easily by using the formula just we have derived. So that is Sn is equal to n by 2 into 2a plus n minus 1 into d. By using this formula we can solve, we can find S76. Otherwise we have simple formula, that is Sn is equal to n by 2 into first term plus last term. So this is also formula, right? So here we have first term and we have last term, so directly we can solve. So now S76, n value is 76, is equal to, substitute n value as 76 by 2 into, maintain brackets, brackets are very important. Here a is minus 5 plus an. What is the value of an? That is minus 230. So in the bracket we have minus 5 and minus 230. The sum of these two terms gives minus 235. So S76 is equal to 76 by 2 gives 38 into minus 5 minus 230 gives minus 235. So the product of these two terms is minus 8930. So this is the sum of given expression. Okay, so by using Sn formula we can find sum of n terms of given AP. Okay, next let us see, this is an interesting problem. So the problem is, here we have 200 logs are stacked in the following manner: 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. Continue like this. In how many rows are the 200 logs placed and how many logs are in the top row? So this is the figure. So these are the logs. So in the bottom row, this is the bottom row, first row. In this row, how many logs are there? It is given that there are 20 logs. In the next row we have 19 logs, and after that we have 18 logs. That means, what is the first term? So in the first row we have 20, means a is equal to 20, and in the next row the number of logs are 19, means what is the common difference? 19 minus 20, that becomes minus 1. So d is equal to minus 1. Like that we have to place in the bottom row 20, in the next row 19, 18, 17, like that we have to place. How many logs we have to place like that? There are 200 logs. Total number of logs are 200. We have to arrange those 200 logs in rows. So the question is, in how many number of rows we can arrange those 200 logs? And one more question, that is, in the top row, how many number of logs are there in the top row? Okay, so let us solve. We have to find the value of n and we have to find the value of an. Okay, so the given values are a is equal to 20 and d is equal to minus 1 and Sn is equal to 200. Okay, so a is equal to 20, d is equal to minus 1, Sn is equal to 200. Now what is the formula of Sn? Right here. So Sn is equal to n by 2 into 2a plus n minus 1 into d. Okay, now replace the known values in this formula. So we know Sn is equal to 200, which is equal to, we don't know, we have to find the value of n, right? So here n by 2 into 2 into, what is the value of a? 20 plus n minus 1, we don't know the value of n, right? So keep like that only, n minus 1 into, what is the value of d? That is minus 1. So these brackets are very important. So next bring here in the denominator we have 2, bring to left hand side, it multiplies 200. So 2 into 200 is equal to n. Here we have n, 2 into 20, it becomes 40, and minus 1 into n, that is minus n, minus 1 into minus 1 become plus 1. Now 2 into 200 is 400, n into 40 plus 1, that is 41 minus n. Next plus into minus minus, n into n, n square. Now rearrange the terms, then bring right hand side term to left hand side, then we will get minus n square become plus n square, 41n become minus 41n, this is plus 400 is equal to 0. So here we have a quadratic equation. Okay, so to solve that quadratic equation we have the knowledge of quadratic equation chapter also. We got a quadratic equation, right? So now we have to factorize that quadratic equation, then we will get a value of n. Now this is the quadratic equation we have seen just now, n square minus 41n plus 400 is equal to 0. Okay, what are the factors? Here the product of extreme terms is 400. The factors are 16 and 25, minus 25 and minus 16. If we add these two terms, we will get minus 41n. The sum of these two terms is minus 41n and the product of these two terms is 400n square. Okay, so this factorization is important. Now what is common in first two terms? N is common. So after taking n as common, we will get n here and minus 25 in second term. In latter two terms, those are minus 16n plus 400. In those two terms minus 16 is common, then what is remaining? As minus 16 is common, here n is remaining, and in 400, divide 400 by minus 16, we will get minus 25. So minus 16 into minus 25 is 400. So these terms should be same after factorization. Now again, what is the common? N minus 25 is the common. So n minus 25 is common. Then what is remaining? Here we have n and here we have minus 16. So n minus 25, n minus 16 is equal to 0, and if the product of two terms is 0, either a is 0 or b is 0, right? So here either n minus 25 is 0 or n minus 16 is 0. So bring 25 minus 25 to right hand side, then n is equal to 25 or n is equal to 16. Okay, so check whether both valid or not. Sometimes terms which we got to n are not satisfied. Okay, so for that we have to check. So here by observing only we can say that how many number of logs are there in bottom row? Maximum we can arrange in 20 rows only. In the last row we have one log, we cannot have 25th row, right? So by using formula also we can say that n is equal to 25 is not possible, so we will check. Okay, so n is equal to 25 or n is equal to 16, right? Now I am going to find a25. That means how many number of logs are there in the 25th row I am going to estimate. So a25, what is the formula for nth term? That is an is equal to a plus n minus 1 into d, right? So a25 is equal to a plus 24d. Now a25 is equal to, what is a? 20 plus 24 into, what is d? Minus 1. 20 means, so in the bottom row we have 20 logs and the common difference is minus 1. So now a25 is equal to 20 minus 24, a25 is equal to minus 4. Is it possible to arrange minus 4 logs? Okay, is number of logs in or negative? No, it is not possible. So this case is not possible. Okay, so it is not possible. Now check for n is equal to 16. a16 is equal to a plus 15d. So a16 is equal to, what is the value of a20 plus 15 into minus 1? So a16 is equal to 20 minus 15 plus into minus, right? So a16 is equal to 20 minus 15 is equal to 5. So this is valid. Okay, so what does it mean? This says that a16 is nothing but in the 16th row we have 5 logs. Okay, so the total number of rows are 16. Total number of rows are 16. In 16 rows we will arrange 200 logs and the last row contains only 5 logs. Okay, so this is the meaning of that expression. So hence there are 5 logs in the top row. Like this we can estimate either a or n or d or an or sn. Okay, so by using given data. So this is the importance of the formula sum of n terms, that is n by 2 into 2a plus n minus 1 into d. Students, till now we have learnt about what is arithmetic progression. The arithmetic progression means by adding a fixed number to preceding term we will get next terms except the first term, right? So if we multiply the fixed number, non-zero fixed number, what happens? we will get geometric progression. So let us learn what is geometric progression. Consider here we have some examples. Here 2, 4, 8, 16, so on. So here 2 into 2 become 4, 4 into 2 is 8, 8 into 2 is 16, 16 into 2 next term is 32. So by multiplying fixed number we will get this sequence. Next what is the fixed number which we are multiplying? That is minus 1. 1 into minus 1, minus 1, minus 1 into minus 1, plus 1, plus 1 into minus 1, minus 1. Okay. So next, the next term, what is the common fixed term? That is 5. Minus 4 into 5 is minus 20, minus 20 into 5 minus 100, minus 100 into 5 minus 500, so on. Here 0.4 into 0.1, that is 0.04, or multiply with 1 by 10. 0.4 into 1 by 10 become 0.04, 0.04 into 1 by 10 becomes 0.04, like that. So these are the examples for geometric progression. Geometric progression is a list of numbers in which each term is obtained by multiplying a non-zero fixed number to the preceding term except the first term. Just now we have seen in the examples. Okay, so by multiplying a fixed number which is non-zero, then we will get next terms, okay, except the first term. That is the definition of geometric progression. Okay, next what is common ratio? In a geometric progression, the ratio between any two consecutive terms is constant. So if we divide second term by first term, third term by second term, so that ratio is constant, that ratio is called as common ratio, and it is denoted by R. The common ratio is denoted by R. So let us see the terms of geometric progression. Let us see the terms of geometric progression. Here A1, A2, A3, AN, so on, AN and so on. So be a GP if each term is non-zero. Why it is non-zero? Okay, I will explain. Here in this one, A1 is called as first term, and A2 is called as second term, and A3 is third term, so on. AN is called as nth term or general term. So if we divide second term, the common ratio is defined as second term by first term and third term by second term. The ratio A2 by A1 is equal to A3 by A2, so on, AN by AN minus 1. So this ratio is constant and it is denoted with R, and that R is called as common ratio. So why here I have mentioned each term is non-zero means here divisible by 0 is not defined. Divisible by 0 is not defined. That's why each term is non-zero. What is the nth term of geometric progression? Here AR square, AR cube, so on. It is a GP. A first term A1 is equal to A. Okay. So by multiplying a fixed number to the first term, we will get second term, right? So the second term is first term into common ratio R. So A2 is equal to A into R, and which can be written as A into R power 2 minus 1. This 1 can be written as power 2 minus 1, right? Next, what is the third term? Third term is AR square. If we multiply, third term means second term into R. Second term, that is A2 into R. A2 is nothing but AR. AR into R is AR square. So A3 is equal to AR square. So here we have 3, here one number reduced. Here we have 2, here one number reduced. Okay. So A3 is equal to what? AR square. That can be written as AR power 3 minus 1, right? So students, can you guess what is next number? What is A4? Just write A and decrease one number in the power of R. That's it. Okay. A4 is nothing but AR cube. A5 is nothing but AR power 4, right? So now question to you, what is A99? What is A99? Yes, A99 is nothing but AR power 98. Only we have to reduce one number, 99th term means AR power 98. So A into R power 99 minus 1. So by this we can generalize the nth term of GP is AN is equal to A into R to the power of n minus 1. Here we have n, here we have to reduce one number. So nth term of GP AN is equal to A into R power n minus 1. Okay. So where n is a natural number, here n should be a natural number. That means the first term, second term, third term, fourth term, that means those are natural numbers. Okay, n should not be a fraction, n should not be a negative. Okay, it should be a natural number always. Now this is the formula. Just now we have seen an is equal to a into r to the power of n minus 1, right? So what is a? A is the first term. What is r? R is the common ratio. What is an? An is nth term or general term. Next, what is n? N is number of terms. So among these four, if any three values were provided, then we can easily find the fourth one. Okay, so by using this formula, nth term formula, we can find the fourth one if three among these are provided. Okay, an is equal to a r power n minus 1 is the nth term of GP. Now what is the general form of geometric progression? So AR square, AR cube, so on, that is called as general form of geometric progression. Here we have three important conditions. One is A not equal to 0 and R not equal to 0 and R not equal to 1. Okay, so students remember these important conditions: A not equal to 0, R not equal to 0 and R not equal to 1. We are going to find the relation between three given terms which are in GP. Okay, here let us take A, B, C, R in geometric progression. If they are in GP, what is the condition? The common ratio should be same. That means B by A is equal to C by B. Second term by first term is equal to third term by second term. Cross multiplication, we will get B into B is equal to A into C, then B square is equal to AC. So this is the important relation we should remember. If A, B, C are in GP, then B square is equal to AC. Okay, so this is the important relation. Now based on this relation, we have one important problem. Let us see. Find x so that x plus 2, x plus 6 are consecutive terms of geometric progression. We should find the value of x. What are the given terms here? X plus 2, x plus 6. It is given that they are in geometric progression. As three terms are in geometric progression, just now we have seen if A, B, C are in geometric progression, then B square is equal to AC. Now by using that formula, we have here x plus 2, middle term is x plus 2, right? X plus 2 whole square is equal to product of extreme terms, that is x into x plus 6. What is the formula of A plus B whole square? That is A square plus 2AB plus B square. By using that formula, we have to expand x plus 2 whole square, that is x square plus 2x plus 4, 2 square, that is nothing but 4, which is equal to here x into x is x square plus x into 6 is 6x. Okay, here x square gets cancelled, and rearrange the terms. We will get 2x plus 4 is equal to 6x, and bring 2x to right hand side, we will get 6x minus 2x is equal to 4. Finally 4x is equal to 4 gets cancelled, and x is equal to 1. Let us see one more example, that is which term of the geometric progression is phi 12. Here geometric progression was given, we have to find which term of geometric progression is phi 12. So in the given GP, we have first term. What is the first term? That is 2. And what is the common ratio? Second term by first term, that is 8 by 2, or third term by second term, that is 32 by 8, which is equal to 4. Common ratio is 4, right? Which term is phi 12 means let us assume an is equal to phi 12. Okay, we should find n, value of n. Okay, what is the formula of nth term formula? That is an is equal to a into r power n minus 1. Substitute here, that is a into r power n minus 1 is equal to phi 12. Substitute the values. The value of a is 2 and the value of r is 4. Here in the left hand side we have the powers of 2, right? Now by using factorization, write the phi 12 as the powers of 2. Okay, so phi 12 factorize like this: 2 into 256, 2 into 128, 2 into 64, 2 into 32, 2 into 16, 2 into 8, 2 into 4, 2 into 2. So these are the factors. So how many 2's are there? 9 2's. So the product of 9 2's become phi 12, right? So phi 12 can be expressed as 2 to the power of 9. Okay, now here 2 and 4 can be expressed as 2 square, 2 power 2 into n minus 1, which is equal to 2 power 9. As bases are equal, power should be added: a power m into a power n, a power m plus n. Okay, so 2 to the power of here 1 plus 2 into n minus 1, which is equal to 2 to the power of 9. Now here base are equal, powers also equal. 1 plus 2 into n minus 1 is equal to 9, and rearrange the terms. 2 into n minus 1 is equal to 9 minus 1, n minus 1 is equal to 9 minus 1 is nothing but 8. Bring left hand side, we have to write, bring to right hand side, 8 by 2 become 4. So n is this is equal to 4, bring minus 1 to right hand side, we will get n is equal to 4 plus 1, which is equal to 5. So that is nothing but, what is the question actually, which term of the GP is 512? So we got n is equal to 5, right? So the fifth term of the GP, given GP is 512. Okay, so these are some interesting problems of nth term, finding nth term of GP. So like this we can find the nth term of geometric progression. So students, in this lesson we have learnt sum of n terms of an arithmetic progression and geometric progression and nth term of geometric progression. So students, go through these concepts and it is time to solve the problems related to sum of n terms of arithmetic progression and nth term of GP. So these are the problems for you, try yourself. Find the sum of all natural numbers between 250 and 1000 which are divisible by 3, and the second one is find the sum of 34 plus 32 plus 30 plus so on 10, and sum of the first 14 terms of an AP is 1505, and its first term is 10, then find its 25th term. And last problem, which term of the GP 2, 8, 32 so on is 2048. Solve the concepts carefully. With one more beautiful chapter we will meet in next session. Okay, thank you.